So I've come to Chiswick in London to see Matt Smith, who is a photographer, but he's taken on a bit of a building project here with this lovely old house. So let's go and have a chat with him.
This was a house that we were very lucky to have been gifted because my grandfather bought it in the 1930s. We're kind of honoured to be able to renovate it in such a way that is, in harmony with the existing building, but also building on it. We've doubled the floor space from something like 95 square metres to 200 square metres by putting basements out the back and out the front, and also a decent sized kitchen out the back as well.
So you decided to take this on yourself and renovate it, yeah?
Yeah, basically the idea is this is going to be our forever home. So I'm personally very invested in it. I know a lot of developers come along, especially in West London, and come and buy something up and whack a load of cash on it. I mean, our money's gone a long way so far, but wherever we've spent a lot of money, we've had to often undo the mess that our contractors have made. It's to quite a grand scale actually. So I say 10 years ago I couldn't put up a shelf. Now I can lay a concrete slab, yeah.
Blimey, you've learned loads, haven't you?
I'd have to call my dad, how do I do this? But now I can lay a concrete slab with reinforcements, suspended staircase in concrete, get an expert at reading the building regs, wiring regs, the whole lot. This little pier here, we actually built that from scratch. It looks like it might have been part of the original building, but we actually built that from scratch because when we uncovered this beam here, this is a very old oak beam, humongous beam, we realised that actually only went into the wall by about 15 mil. And when I saw that, and I looked and kind of pulled a bit of the pointing out, which is just kind of black dust by this point, I saw that and we basically freaked out. So we basically built all the way down to the lower ground floor. Actually, that's in engineering down there, but this is in kind of nice reclaimed London stock brick, so that's supported there as well. Also, this actually takes about 4 stories of brick on top of it, believe it or not, even though it's inside. And there's doors across there to the mezzanine levels. Our builders had left a whacking great hole in the most structurally important bit, which is this corner. So we had to go and kind of uncover that and rebuild it. Took a week, and then I thought, you know what, I want to put some bolts through here and turn this into a flitch beam. Obviously that's all got to be covered up. It goes onto a steel that goes across underneath. Some of this was slightly an afterthought, so for the reason that we've got this bolted plate is because the steel was not spec'd correctly in the first place. I actually noticed this at the time. The structural engineer said no, it'll be fine, and then sure enough afterwards I said we're going to need to add a bit here, because we've got to take this steel here.
Doing that with steels, a number of steels where you've got to tack a bit on or take a bit off or whatever.
Yeah, the thing about this building,
mobile welding services.
Yeah, the thing about this building is it's a listed building, so it's from 1845. It was built, so it's actually, I think it was designed in 1839.
So what, grade 2, grade 1?
Grade 2.
Grade 2.
Yeah. These steels unfortunately shouldn't be here, but the reason that they're there is because the basement company who came and dug this basement and put the suspended slab, this is concrete slab on top, they didn't put the correct reinforcements in, and at this time, this was only shortly after I couldn't put up a shelf, and I didn't know how to read structural engineers' diagrams at all. I just trusted that they were going to do it correctly, and it was a big mistake doing that, I tell you what. My biggest piece of advice that I would give myself then would be, if you want to switch off to the detail, just don't. Just spend the extra mental effort in understanding the diagrams and making sure that it happens, because we've had guys come in, this is the basement company, who've put their sewage pipe in with a fall the wrong way, back into the house.
Fall,
and actually there was some really bad conduct. Anna came along with a spirit level and said, the fall's going the wrong way, mate. And one of them lost it, chucked a hammer down, and it went up and hit her head.
Oh no!
Thankfully not the metal bit, but they were sent off site that day. But these are the kinds of,
so
issues
just by
you do.
saying to the guy, you've got the fall going the wrong way, he throws his toys out the back. Actually,
the one guy who we were addressing, he was all right, and he's a nice enough guy. It was the other guy who'd spent a bit of time doing something, and none of them are plumbers. They're just guys who use buckets and wheelbarrows and whatnot. So we've had to keep our eye on absolutely everything, but unfortunately this slab did develop some signs of structural issues. So a suspended concrete slab, you don't want to see cracks in that. You can see cracks in walls because you get a bit of subsidence and you expect that a little bit, but in a suspended concrete slab, you don't want to see a crack. And what we saw were cracks that were kind of heading towards a point load, which is there's a steel, which is upstairs, that was that point load. And we were scabbling off the concrete down here one day because another story, but the concrete that they'd laid had a 70mm variance in height. Can you believe it? Well, you can't waterproof that. So we had to scabble that all off, and we did a nice bonded screed when it was all cleaned off. It took weeks and weeks to do this. It's beautiful and flat now. But whilst we were doing that, I looked up and I saw these cracks, and I thought, you shouldn't really have that in a suspended slab. And so we went back and we got some advice from a concrete expert, and he said, show me the photos of when they laid it. He said, you've got no reinforcement in your concrete like you should have on the structural diagrams. And I said, what do you mean? There's loads of metal all over it. There's all this mesh stuff, 2 layers of mesh. That's got to be good enough. And he said, mesh isn't the same as reinforcement. Mesh and reinforcement are 2 different things. Yeah, they're metal bars. Mesh is, the crisscross metal bar, but that's not, that's for localized, to avoid localized curvature.
Yeah.
But reinforcement is something that is different, and we're expecting 12mm bars to go in.
To stop it bending.
To stop it bending over this wall, and they should have come out from the edges. That didn't go in at all, so we had to retrofit these steels, which is another.
How the hell did you get those steels down here?
Thankfully, we got a steel guy who wasn't the same as the guys who did the original job, and they spec'd it out and did a really lovely job, and we had to cut holes out there, and then we actually, on this side, I believe we put a kind of a plate, a bracket, with big M12 or M16 actually bolts, resin fixed into the wall there. And of course we had to waterproof around everything, so because these are all potential places where the water could get in.
You leave one tiny little bit and that's the bit, isn't it?
Absolutely. So that's why we've got this slightly annoying structure. This would have been beautiful had it been, a proper suspended slab. We didn't make that mistake in the front basement. Actually, the guys who dug our basements block and beamed the front. They didn't even put a suspended slab in there. They block and beamed it, and then they put concrete on top, which looks great from outside, but the thing with block and beam is, I'm sure loads of people will disagree, it bounces. I'm sure a load of people will say, oh no, it's absolutely fine block and beaming, you're sorted, just use the heavyweight blocks and you'll be fine. We live on a high road with 4 lanes of traffic and buses going past, all times of day and night.
They do bounce a building, I know that.
Yeah, they bounce, and the thing is, waterproofing for a basement, you really want to make sure the movement is minimised on your concrete structure. So when we go into the front basement, I'll show you. We don't have any of this rubbish because we actually redid the roof from scratch ourselves. So what we did in our front basement is we took up their block and beam, and we took up their concrete, 100mm of concrete that they put on top of the block and beam. Built a deck out of plywood, and then we lay a new concrete slab. I mean, I'm making it sound easy, but I tell you what, it was weeks and weeks of work. This wall should have had bars that had come up about, I think it was 1 metre, it was spec'd and bent round, and then set into this concrete.
Got it.
Well, we had to retrofit those bars. So there's me laying on my front. I think it took about 3 days getting all the bars in with a big long drill bit, SDS bit this long, and I think we went with 10mm bars, which was recommended to us by this chap we spoke to eventually. And we had to actually buy pre-bent bars.
I was going to say you had to get them bent.
I mean, normally people will bend stuff on site, but the chap we spoke to wasn't having any of that. He said no, it's much better to have them pre-bent, just for the strength of the bar actually, because they do lose. Yeah, when you bend them, they lose some structural integrity. I'm sure everyone will disagree with that, but we retrofitted bars all the way around, blowing dust out. Got through about 3 dust blowers, believe it or not. Resin fixed the whole lot in, and this concrete slab is 215mm thick. We use these very special reinforcement bar spacers, not just the standard spacers. Not the standard stuff that you can get. But you get these cementitious, or actually they're porcelain.
I know the ones.
Bars.
Yeah.
They're absolutely brilliant, and everything had to be obviously make sure there's 40mm of cover on all reinforcement at an absolute minimum. But this was done to a very, very high standard. This is thanks to a chap who we actually wanted to get someone else to do this, because at the time I didn't really feel up to it. I saw other people messing it up and thought I can do a better job than that. Then it got closer to the time of doing it, and I thought, do I really know what I'm doing? I got a bit of self-doubt. So we called a number of concrete companies. I found 10. I called 10 of them. 3 of them called me back. 2 of them said they'd turn up. 1 turned up. zero quotes.
Oh,
No
really?
one wanted to touch
Goodness,
it.
yeah,
So I then thought, well, what am I going to do? I've got to solve this problem. So I went through expert witnesses, not with a view to taking legal action, but because these guys know their stuff.
Yeah, I know, yeah.
And I found this gent who was a retired concrete expert. He wrote one of the British standards on concrete spaces just himself. Most British standards are
Committee,
written they're by committee, but this is one of the only ones that was written by just one guy. And he came and he taught us everything he knows about concrete. Spent 2 days. He spec'd all of it. He was there on the day of the pour, and we are really, really pleased with how it's turned out. But this is very, very, very pleased with this concrete. In fact, we've not even waterproofed over the top of it with any liquid membrane or anything, and water just doesn't come in. It's fine without that. So.
Are you going to waterproof it?
Yeah. So we're
Eventually?
using a Newton Acreflex liquid membrane, and all around the sides we built up little concrete upstands. You can build them in brick and whatnot, but we were advised by a Newton guy came round actually and talked to us, and he said if you can build them out of concrete with a bit of bar in there as well to stop movement, he said you will have a waterproofing system that will literally never fail. Because if you've got different materials, they expand at different rates, and so you get different. But with concrete and concrete, with little fillets between them as well, and cementitious fillets. We've done all of that upstairs, and that's ready for the waterproofing to go on. When the water comes in, it gets pumped out. And this
You're saying when? Because it's going to happen.
Well, it's happened twice already.
Yeah.
Once was when we hadn't done any fit out. We've got screeds and insulation now, and I've got electrics. We're first fit. There's temporary electrics in.
Yeah.
We can't have from this point onwards. We really can't have a flood. But this will prevent it. I haven't actually installed any monitoring system for this one yet, but I will. So that if any water comes in here, then there's a problem. What I'm doing at the moment is I'm monitoring the sump, which is just down there, and if that goes off, because when the sewage backfills, it kind of it tries to stop here. That's where the non-return valve is, so it doesn't go back there, but this starts filling up.
Got it, I see.
But of course, when this is pushing back on the non-return valve, our own sewage can't come out, and there's rainwater coming from the top of the house trying to get out. So it will flood the light well, it'll flood in here because these sumps will try and push it out, and it's got nowhere to go. So it'll push it out and it'll go straight back in there. So I've got a little kind of bit of programming that I've done that I'm able to see when the sump has tried to push out more than 3 or 4 times in 5 or 10 minutes, then it's obviously not getting rid of it properly, it's just coming straight back in again.
Yeah.
So I get a notification on my phone saying, like, sewage alert, drop everything, leave work, come home, there's going to be a disaster, you're going to be up all night. Which has happened too many times now. But this is something that should never happen. But Thames Water, they don't even compensate you now. I mean, they barely even answer the phone when it happens. It's a pretty bad state of affairs. So that's my crazy waterproofing system and flood management system. You wouldn't think in the first world, in a lovely part of London, you'd need something like that. So unfortunately, what you get when you have this amount of structural glass is, you pay an incredible amount of money for an install team to come along and spec this up. And it's a difficult build because nothing in this property is square. I mean, they never are, but this is particularly unsquare. Unfortunately, I know they didn't put any membrane between that wooden upstand and the aluminium. From the outside, I've cleaned it all off and I've gunned some CT1 into it. And I think water is now not getting through between the two. I think it's getting through in the silicon join between the glass and the aluminium.
Like being in a fish tank.
Yeah. I mean, it's lovely in the summer. I mean, you can imagine the amount of light that comes in.
Yeah.
This was spec'd by the architect all those years ago, 7 years ago.
Yeah.
And the idea is that we needed to keep the level of the roof down, at the side with our neighbour. Our planning permission depended on that. This is kind of important to the actual planning permission as well. Inside this U-channel, I've been able to see that they've screwed inside the U-channel, because I can see, if you get a torch and just look through that gap, you can see the screws, and I know exactly where they all are. I've marked them all. But they've screwed inside there. Obviously they've not sealed those. I think what's now happening is it's getting through the silicon join on the outside, filling this U-channel up, coming through the screw holes, which means we're completely up the creek.
So you're accepting the fact that you're going to get water then?
Yeah, that's right. And that's
you're not.
Well, unfortunately, I noted that one of another excellent skill builder video that I watched once was where you install these frames. You have a membrane that goes underneath, and then it laps up onto the level of the screed, so that any water that gets in, it can't go further because it's literally you know, gravity will mean it just go. It might pool there underneath, but it'll eventually go back out again. There is no such membrane, so what the guys did is they did a bodge, which they tried to do up there, and it came off. And this is this EPDM stuff, which they've siliconed to the frame.
Yeah, that's just roof material that they've just got a strip of that.
Yeah, but I mean, imagine if this silicon join just kind of goes anywhere, then water's going to come in.
So we've got the weep holes, basically.
So we've got the weep holes. It's very difficult to know whether it's coming in through here or somehow kind of like building up under this membrane, which I really do plan to take off because I think it's as much use as a chocolate fire guard. But it's getting in under here, and I know it is because when I shove my little finger down this hole here, it's wet. And then there's a hole in this screed, which was my services. Out of the bottom of that hole in the basement, if you look up, water's dripping out of that hole. It's a tale of woe and a half, and you know what, people, when you first mention that you're doing a self-build, they often think, or, you know, you probably caused a lot of problems. Yeah. But I can tell you every single time that we've got someone else to do something, because I've not been able to put tons of glass on a roof myself. No. Every single time we've got someone else to do a problem, we've had to solve their problems.